Hi, I'm Rich with insideHPC. We're here at the GPU Technology Conference in San Jose, California. And today I'm here with Greg Schmidt from Hewlett Packard Enterprise. How you doing today, sir?
I'm doing great, Rich. Thanks for interviewing with me.
Well, great. It's good to be here. I figured we should start at the beginning, though. Who is Hewlett Packard Enterprise, and who do you help?
Sure. Well, recently HP broke into two companies.
Yeah.
Hewlett Packard Enterprise is the portion that serves enterprise customers. Servers, storage, networking, enterprise services, the big customers.
Okay.
On the other side went the printers, PCs, consumer stuff mainly.
Okay. So you're the enterprise side of things, of course.
Absolutely.
So what are you showcasing today at the GPU conference?
Glad you asked that question, Rich.
Yeah.
We've got the Apollo 6500 system.
This shiny box here?
This shiny box right here.
Yeah.
This is really special. What we've got is it's really a system. There's a chassis that's not shown here, but it's over here. We might look at it later.
Yeah.
A server tray, and then a power shelf that supplies the power for the system. I'd like to focus on what's holding the GPUs, because that's where all the magic is, and that's what this conference is about, GTC.
Okay.
Inside of the Apollos, this is the HP Enterprise Reliant XL270D accelerator tray, Gen 9. What that means is that it's a Broadwell system, 2P, two processors, up to a terabyte of RAM. That's not what's really interesting about this. What's interesting about my product here is it holds up to 8 NVIDIA GPUs.
8 in a 2U space.
8 in a 2U space.
Okay.
So let's take the K80 as an example. I'm holding the K80 here. This K80 has about 4,900 and something cores. Let's call it 5,000 cores. It puts out about 300 watts in steady state. So 8 of these in a system, you're talking 5,000 cores times 8. That's 40,000 GPU cores. When we're talking GPU processing power, this is it.
Okay. A lot of density, compute density there. That's got to put out some heat. What are we looking at there? How do you manage that?
Well, we mentioned 300 watts roughly per K80.
Yeah.
You got 8 of them, that's 2.5 kilowatts. You figure your fans, your CPU, your RAM, etc. You're pushing 3 to 3.5 kilowatts. Depending on what's being worked. It's a lot of power to take out of a 2U space. And this is actually designed so that you can fit 2 trays in a 4U chassis. So you're looking at on the order of 7 kilowatts of power out of a 2U chassis. That's a lot of power.
It's a lot of power.
Brings compute down.
Okay. Well, of course, we're at the NVIDIA conference. Can this chassis accommodate other kinds of products as well in the accelerator space?
Absolutely.
Yeah.
We'll support AMD. The S9150 is an outstanding high-performance computing card.
Yep.
And towards the end of the year, Intel will be bringing out the Intel Xeon Phi Knights Landing version. We'll absolutely support that. What's more interesting, really, it's not just the cards, but it's how we've configured the cards to work with customers' workloads that's more interesting, I think.
Yeah. All right, Greg, so with all this kind of compute power in a small space, isn't it a problem to move all that data into the thing and out? Well, what kind of network are we talking about?
Yeah, Rich. Getting data onto the machine to be crunched, getting it off, reloading, big problem for customers.
Yeah.
What we've done is that, I mentioned the high-speed PCI Express fabric before.
Yeah.
We're pulling 2x16 lanes out front for low-profile PCI Express. So you can support 2 full InfiniBand EDR or Intel's new Omnipath architecture as it comes up, as it's available.
Yeah.
And we got 32 lanes of PCI Express support for that.
Okay.
Lots of bandwidth. Gets the data in, gets the problem solved, turns it into something people can use, makes money. It's good for everybody.